Happy snow day. Here's a video for Unit 9, Section 2. These are the 5 events or 5 topics we're going to cover. It's going to look like a long one, but there's not much to write on each slide. So here we go. The rotation of the Earth causes sometimes people say optical illusions, but it really does cause the global winds blowing around the Earth to curve. And this is actually going to create 4 different wind zones, in each hemisphere. So basically the same things happen in each hemisphere, northern and southern hemisphere, just in opposite type directions, as you'll see just in a few minutes. So the Coriolis effect is caused by the rotation or the spinning of the Earth, and it does deflect things to the left or right depending on which hemisphere you're in. So there's 4 major wind zones. The doldrums, which are around the equator, air is usually calm there. The trade winds, which exist between 30 degrees north and 30 degrees south of the equator. This is a little bit south of us. And then the prevailing westerlies between 40 and 60 degrees north and south. This is where we reside. Our weather always comes from the west. Prevailing means constant, westerly means from the west. And then at the poles, north and south pole, there are the polar easterlies, and they blow the other way. So each wind zone blows in an opposite direction from the previous wind zone. There's an actual second video I want you to watch that will show you this. That's why I've not included a graphic. Along with these global winds, you have the jet stream. You probably heard of the jet stream, and it's a really high altitude. It's almost like a river of air. It moves really fast, as you can see in that first bullet. About 185 kilometers per hour. That's somewhere around 100 miles per hour or greater. It's pretty high in the troposphere, 10 to 12 kilometers, and it's what moves all of our weather systems around the globe. In our wind zone, it typically moves from west to east. That's why it's a westerly wind and prevailing westerlies. There are 2 branches of the jet stream that affect the United States, the northern and southern jet, and they affect our weather in different ways in different seasons. Okay, the next thing we want to talk about are fronts. These are the edges of air masses, and when 2 air masses meet, they create a front, sometimes called a frontal boundary. And weather happens when fronts meet. I mean, some different weather, not just fair weather, but rainy weather, stormy weather, etc. So let's look at the 4 kinds of fronts. The first kind of front is a cold front, and you can see up in the upper right hand corner, that's the symbol of a cold front that you would see on a weather map. And when a cold front comes into warmer air, the cold air is usually denser, and it kind of pushes up under the warmer air, and kind of like nosing under something, like a cat would nose under the covers. This is usually when a cold front gets into a warm front, especially in the summertime. This creates very heavy rain and lots of storms. It doesn't last long. As the front moves through, the thunderstorms pass through, and 30 minutes later they're usually gone. And then usually there's dry weather behind the front. The second kind of front is a warm front. And the warm front, as it moves into cold air, it overrides the cold air. Warm air rises, so it rides up over it. It's kind of like a big truck with a head-on collision with a small sports car. It's going to ride over top of it. And this usually causes some precipitation, but it's nothing like the cold front. It's light precipitation, and it's usually kind of lengthy. It's like that slow, steady rain. It's usually followed up by hot and humid weather afterwards. So when a warm front is the leading edge of warm air, and especially in the summertime, it's going to be humid after because it's just rained. The stationary front is exactly what it sounds like. The 2 air masses meet and neither one moves, so it stays there. This can provide your incredibly long 2 or 3 day rain event. It's just the same weather sits on top of the same place the whole time, and it doesn't move until something moves it, like a high pressure system or a low pressure system nearby. That will sometimes move it. An occluded front is it's kind of like a cold front, but it kind of like pushes the warm air up, as opposed to just colliding with it. And weather can be different things. There can be some rain with it. It can be some cloudy weather with it. It doesn't have quite the same characteristics as a cold front or a warm front, but it's also similar to each. So high pressure air under high barometric pressure tends to sink, and because of the rotation of the Earth, it spins, and in the northern hemisphere, it spins clockwise. So think about that again. High pressure air sinks, it spins clockwise, and winds move outward at the base on the surface. So as the air pressure pushes down the Earth, it turns to the right or clockwise, and winds push outward from a high pressure, because wind moves from high pressure to low pressure. And it's also called an anticyclone. It's because the next one is called a cyclone. A low pressure system is less dense, so the air rises. This is called a cyclone. Big tropical cyclones are known as hurricanes. Warm air is usually humid, rises in the center. The winds blow towards the center of the low pressure, not outward, and that's what causes the rising air. Okay? As I said, these are called cyclones, and the tropical ones are called hurricanes. So if you have a high pressure system somewhere in the United States and low pressure somewhat nearby, wind's going to blow outward from the high pressure to the low pressure. And this is basically the basis of all of our weather. Okay, that's it. Don't copy this one down. That'll be the end of this section. Have a good day.